Good morning, YouTubers. It is August the 11th, 2019, and right now I'm going to talk to you about the General Radio 1304A audio oscillator. Actually, they call it a beat frequency oscillator, because it's not like a normal oscillator where you have the oscillator section and then they have a buffer and an amplifier. They actually heterodyne or beat two different signals together to get the output frequency. So that makes it somewhat unique, I think. I checked the price just to show you how crazy eBay can be. Somebody on there has one of these things for $400, which is insane. If you pay that kind of money for this unit, you need your head examined, first of all. Second of all, I came upon this unit at a ham fest, and otherwise known as a ham radio flea market, from a couple of guys from the Bronx. I was talking with them, and I bought this and a linear, or I should say an analog power supply. I think it was a variable supply. It went from 0 to like 18 volts DC, rack mounted, built like a brick outhouse. I bought that and this for $5. That's $5 US. They went to a few ham fests with this stuff and nobody was even remotely interested. So when I raised a question, they were willing to give me both units for free, but I felt bad. So we settled on $5. So there you go. I had this operating a few years ago. It did work. What happened the other day, I decided to drag it out and hook it back up again, and I found out that it wasn't working. Well, I looked down onto the tube section of it, into the circuit area, and the voltage regulator tubes were not glowing. The old vacuum tube voltage regulator tubes will glow. Well, these in particular, the the Ocean Delta 3, OD3 tubes, glow a really nice purple. And they weren't glowing. I did some checking and I found out that they were being supplied with 90 volts of DC, and that was the problem. The two regulators, the two OD3 regulator tubes that are in series, they regulate voltage to 150 volts. They were only receiving 93 volts, so the tubes were not turning on. I just want to show you a couple of things real quick about this unit. So before I get into the circuit part of it, I'm going to spin this around a little bit. As you can see, it's very well built. Kind of a cool rig, really. The regulator tubes sit over here, and the rectifier tube sits there. If you have any old equipment and you want to change the rectifier tube out and put regular diodes in it, I would ask you to rethink that situation, because what happens is there'll be high voltage delivered to the tubes before the heaters are warmed up, and that's not a good situation. It'll bang out your tubes pretty quick or shorten the life of them substantially. Something I also noticed on this, let me see if I can zoom in a little bit. You see tags right here. They're plastic tags with the tube numbers on them. Usually you see that engraved in the chassis, but that was the first time I've ever seen it done this way. And so it's pretty cool. So you can't really mess up the tube tube alignment unless you're not paying attention. So so there you go. All right, to get back to the original problem, I was not able to see the tubes glowing. So what I ended up doing was I did some voltage checks, and of course the supply was way off. The raw DC supply from the transformer was fine, and the rectifier tube was fine. So this is what I pretty much found next. I'm going to come over to the whiteboard. Let me zoom out a little bit here. I'm trying some new stuff today. I've got the what do you call it, the tripod here, so I don't make you guys too seasick like I usually do. Of course, the capacitors, the electrolytic capacitors, these three right here, there are 3 units altogether. There's 2 40 mic caps in the first one, 2 in the second, and 4 20 microfarad caps in the third, and they're all 450 volts. So I started looking at them, and as you can see these big red dots here, I saw some schmutz right here on these 3 areas, and that tells me that the capacitor is leaking on the inside. I don't believe in reforming. Anybody that's seen my videos knows that. So I'm going to replace all of those. I checked on getting replacement capacitors, and these can type capacitors are very expensive. There's a lot of companies that do some very fine work, but I wasn't looking to spend several $100s or $150 to recap this old piece of equipment here. Even though General Radio made some fantastic equipment, very well built and all that, but let's face it, this thing's about 50 years old, and it's an audio oscillator, so I'm not going to use it all that much. I have audio oscillators built in the URM25D, the video that I just put out, I think about 2 weeks ago. I did find not only that these capacitors are leaky, but as you can see from up here, hopefully this will come out, this resistance network. It was made by the IRC Corporation, and it's a flat, looks like a flat piece of metal bolted to the chassis, and it's got tabs sticking out of it. So what's happened was, if you look up at top, the 1 kilo ohm resistors, the 1K resistors, are part of the voltage dropping network that feeds the voltage regulators. Now I found 2 resistors that they weren't open, but they measured in the high mega ohm range, and that was another part of the problem. So it's a 2-pronged problem. First, I'm going to replace the capacitors, and then I've been trying to do research. This is the IRC part numbers on the bottom. I'm trying to do research to see what exactly are the wattages of those resistors. If I can't get any information out of an old IRC catalog, I guess I'll have to use Ohm's law and figure out what the wattage or what the dissipation is on those 1K resistors. So now, how do you check a unit like this? Well, what I did was I put the negative lead here, positive lead here, measure 1K. Leave that lead there, leapfrog it over here, get another 1K. Now when I moved it to the second position, I received a high mega ohm reading here and a very high mega ohm reading here, meaning these 2 resistors out of that unit were compromised. Now to repair it, I know you're thinking, why don't you just bridge a couple of 1K resistors on here? Well, you don't want to do that, because like I said, these resistors have not completely failed. If I put one in parallel, a 1K in parallel with either one of these, who knows what kind of resistance I'm going to get out of here, because the two resistors in parallel, it'll probably end up where it'll half the 1K resistor. So I'll end up with 500, 300, 200. I have no idea what kind of ohm reading I'm going to get out of that if I do that. So I'm going to have to either eliminate this completely, or just find a way to reroute this so I can put two 1K resistors in here. I'm guessing they're probably, I don't know, anywhere from 2 to 5 watts, but I don't know that for sure. You check this 450 ohm network the same way. You put the lead here, you check for 450 here, you check for 450 here, check for 450 here, and this one was fine. So I've got two problems. I've got a couple of 1K resistors that went south, and I need to replace all of these electrolytic capacitors. So that's where I am right now. I will get back to you guys at a later date when I figure out what the deal is. Let me move back to the radio here. I think you could see where I marked the capacitors. Those are the offending caps right there. So I'm going to have to replace them. I don't know if I'm going to put some kind of a board in there or what. Some guys would go nuts and hollow out the capacitors and put new ones in there, but I'm not going to go that far. As long as the thing works, I'm happy. Whoever inherits this after me, if they want to do something fancy with it, they can. My whole thing is to just get it working again. So that's where we are right now. I will get back to you on repairs, and I just wanted to show you the back side of this before we go, the underside. Let's see, I'm sure I threw everything out of focus here. I promise not to make you guys seasick, and guess what I'm doing, but here we go. Now look at the way this is built. Point-to-point wiring, but it's all harnessed and looking good. Of course, I removed all the shields, but look at the quality of the workmanship. And those tube sockets, you notice they're ceramic and not phenolic, because they offer more stability. It's a higher quality tube socket, and it makes these things a real delight to work on. Now, this right down here is what I'm talking about. That's one of the units. That's the 450 ohm resistor. Every one of these units represents a 450 ohm resistor. Now the 1K resistors, alright, that setup is considerably smaller, and it's right there. Every one of these is a 1K resistor, right on down the line. And it's these two that are bad, the top two right here. I was able to tell how these capacitors were leaking, because at the bottom there's usually a symbol. It's a triangle, semicircle, square, and sometimes it's just not marked, and that's delineated by a line. Well, when I looked in the symbols, there was a black dot oozing out from where the symbol should be visible. So what happens is, in this closed-in environment, you get something cooking in here, it's got to escape, it bubbles up along the leg of the capacitor or comes up through the symbols, because this is just a phenolic covering here, and that's how you could tell it's bad. I did not measure them. I did a visual look at them. I did measure them with the ohm meter, and they don't show shorted, but they're definitely leaking. And the problem is, when you get a capacitor that wants to turn into a resistor, it will draw current to ground, and all the resistors that are in series with that capacitor will take on higher current and eventually burn out. So that's why it's important to make sure you check the electrolytics, and in something this old, you really want to change them out. You don't really want to mess around with them. What else? Yeah, also, I wanted to warn you, Every video that you see on the internet about this sort of thing will tell you that there are voltages in here that will kill you, or absolutely ruin the rest of your day. So I'm going to tell you that too. If you don't know what you're doing, find somebody who does. Make a nice little project. And as I turn this once more, have fun with it. Be careful. If you don't know what you're doing, find somebody in your neighborhood that does. And we'll call it quits for now. So for now, I'll say 7-3 to everyone. Best wishes, best regards. This is WA2BMB, Alex in Western Central New Jersey, saying bye-bye for now with the General Radio 1304A repair.